So next we'll study like if there is a if there is a resistor, then we'll use. If there is a inductor, then we'll use cell. If there is a capacitor, then we'll use capacitive reactor, right? Now what if there is a combination of R and L, R and C, and the combination of R, L and then in that case will use the term impedance. Okay, I think you have studied in the 11th 12th class also about the impedance. Impedance is denoted by Z. Z is equal to, what is the formula for this? Root of R square plus XL minus X square. Now for RC, what is the formula? If RC there means there is no inductor, and if there is no inductor then there would be no XL, right? XL would be equal to 0. So in this case, impedance formula will become R square plus XC square. Now again, R and L combination is Z is equal to root of R square. There is no capacitance, no capacitance, capacitive reactance, that would be XL. So all are the form of impedance, all are the form of, everyone is having the same unit, that is ohm. Clear? Always remember, we'll never have the combination of L and C. Why? Because it will form an L oscillation. Remember, you have studied in 11th class also LC oscillation. No one is there to consume energy, right? Inductor stores energy in the form of magnetic. Capacitor stores energy in the form of electrical. So both are there for the storing energy. No one is used to consume the energy. Whenever we'll have energy to the inductor, he will capacitor, then same thing. So for consuming of energy, we'll always need to have resistance, right? That's why inductor and capacitor are also known as imaginary component. Okay? Why? Because they never consume energy. And imaginary component is denoted by the term J. Clear? So we'll always write down like JXL instead of XL. What does this J shows? That it's an imaginary component. Why it is known as imaginary component? But because it does not consumes energy. Correct? So it would be J into XC. Clear? So whenever we'll have the combination of impedance like R and L, so we'll write down it like this: Z is equal to R plus JXL. Clear? Now if we'll have the combination R and C, then we'll always write down Z is equal to R minus JXC. Okay? For capacitor, we'll always use minus. Why is it so? Because as I told you, X is equal to 1 by j omega c, right? So, j, we will never leave the j term in the denominator. We always take j term in the numerator. So, we can multiply it by j and divide by j. So, that would be j divided by j square. J square is how much? Minus 1. Like it would, iota square is minus 1. Similarly, we'll have j square is equal to minus 1. So minus 1 into omega c is minus j by omega c. So we can write down minus jxc. Okay. You need to remember for RL we need to use this formula. For RC use this formula. And for the combination of R, L and C we'll use the formula for the impedance, that is RZ is equal to R plus J of XL minus XC. Understood?